Good morning, everyone. My name is Manikumar. Today, my topic is about permanent magnet synchronous motors. The permanent magnet synchronous motors is same like synchronous motors. The only change in is that the electromagnets are replaced by the permanent magnets. Means in electromagnets we can control the flux quantity by varying the rheostat, but here the flux quantity is not controllable. So because of this property, we have some advantages like high torque to weight ratio, high flux density, high power factor, low noise, smaller volume and size, longer life, superior dynamic performance. The PMSMS are widely used with the current controlled voltage source for industrial traction and applications. Because of their excellent properties in industrial applications, servo motors demand constant torque region, and in traction applications, both constant and constant power region are necessary. Due to these properties, PMSMS drive is also called character for aircraft and vehicular applications, where its credibility is most crucial feature. Construction. Sinusoidal or quasi-sinusoidal distribution of magnetic flux in the air gap. Sinusoidal or quasi-sinusoidal current waveforms. Quasi-sinusoidal distribution of stator conductors. Surface mounted PM permanent magnet synchronous motor. In this construction, the magnet is mounted on the surface of the rotor. This is suitable for high speed applications. As it is not robust, it provides a uniform air gap because of the permeability of the permanent magnet, and the air gap is the same. No reluctance, torque, high dynamic performance, and suitable for high speed devices like robotics and tool types. Buried PMSM or interior PMSM. In this type of construction, the permanent magnet is embedded into rotor as shown in figure below. It is suitable for high speed applications and gets robustness. Reluctance torque is due to saliency of the motor. Working of PMSM. The working of permanent magnet synchronous motor is very simple, fast and effective when compared to conventional motors. The working of permanent magnet synchronous motor and the rotating magnetic field of the motor and the constant magnetic field of the rotor. The permanent magnets are used as the rotor to create constant magnetic flux, operates and locks at synchronous speed. These types of motors are similar to brushless DC motor. When the three-phase AC supply is given to the stator, it creates a rotating magnetic field, and the constant magnetic field is induced due to the permanent magnet of the motor. The rotor operates in synchronism with the synchronous speed. The whole working of the PMSM depends on the air gap between the stator and the rotor with no load. If the air gap is large, then the windage losses of the motor will be reduced. The field poles created by the permanent magnet are silent. The permanent magnet synchronous motors are not self-starting motors, so it is necessary to control the variable frequency of the stator electronically. Modeling of the PMSM. For proper simulation and analysis of the system, a complete modeling of the drive model is essential. The motor axis has been developed using a DQ rotor reference frame theory. At any particular time t, the rotor reference axis makes an angle theta with fixed stator axis, and the stator MMF creates an angle alpha with the rotor D axis. It is viewed that any time t in the stator MMF rotates at the same speed as that of rotor MMF. Main points. Saturation is neglected. Induced EMF is sinusoidal in nature. Hysteresis losses and eddy current losses are negligible. No field current dynamics. Voltage equations from the model is given by V equal to R RSIQ plus omega R lambda D plus rho lambda Q VQ equal to RSIQ plus omega R lambda D P lambda Q 1. Flux linkages are given by equations 3 and 4. The mechanical torque is equations given TA equal to TL plus B omega M and so on. PMSM drive system. The motor driven drive essentially consists of four main components such as the PMSM, the inverter, the main control unit, and the position sector interconnections of the components permanent magnet synchronous motor drive. One of the major disadvantages of PMS drive is torque ripple produced, which can be attributed to the following sources: mutual torque due to interaction of rotor field and stator currents, reluctance torque due to rotor silence, cogging torque due to existence of stator sluts. In this section presents application of fuzzy logic to denigrate the torque ripple associated with the field oriented control. When used in control of a SVPWM based on FOC with fuzzy logic is proposed to introduce an effective selection of the shutter voltage to vector to obtain smooth torque performance. The significant advantage of the space vector modulation are the ease of microprocessor implementation. The block diagram of the proposed FOC with fuzzy logic based controller with the PMC drive shown. Simulation results are here are the simulation results. Torque output for FOC based PMSM using FLC. Torque output for FOC based PMSM using FLC and SV PWM. Applications: industrial drive pumps, plants, blowers, mills, hoist handling system, elevators, escalators, people movers, light trailers and street electric road vehicles, aircraft flight controls, surface actuation. Disadvantage: there is a risk of demagnetization of the poles which may be caused by a large number of armature current. Demagnetization cab may also occurs due to excessive heating and also when the motor is overloaded for a long period of time. The magnetic field of the PMDC motor is present at all three times, even when the motor is not being used. The permanent magnet produces a high flux density as that an external separate center field does. Therefore, a PMDC motor has lower induced torque per ampere turns of the current. Conclusion: the permanent magnet synchronous motor drives gaining more and more popularity in the variable speed field due to their enhanced controllability, the high torque to weight ratio attempted to unfold and ratio and better dynamic performance. This is an attempt to unfold the excellent performance of PMSM permanent magnet synchronous motor drive, which is controlled by field oriented control FOC technique used for wide speed operation.